Okay, in this video, I want to showcase this 3D outline technique. To get a result like this, which has an outline thickness parameter and a color wheel, I used a method called the inverse Hull outline. It's surprisingly simple and pretty reliable. The first thing we need to add is a solidify modifier. We'll set the offset all the way to 1, so that our thickness scales outward when it's a positive. Now we basically have a clone of our mesh that we scale along its normals. It should look a bit puffed up or inflated, but that's obviously not the look we want. We still need to flip these outer normals, which we can do under the normals panel and select flip. I'm using a toon shader, so it doesn't look different for me, but if I switch to solid view, we can see our shading is messed up because our normals are flipped. Now add in a new material and call it outline. Make sure to lower it so it's the bottom material slot. Remain in your outline shader and select backface culling. It's a small checkbox under settings. You can only do this in the Eevee render engine, but if you want this in Cycles, copy the shader setup shown on screen and recreate it in your outline shader. It's essentially backface culling, but for Cycles. Finally, you can count how many rows down your outline material is. In my case, it's 1 below the top. Material offset chooses the materials for the solidify modifier's outer shell. That means if I shift the material offset by a value of 1, we get a nice outline. Here's a white background so you can see it better. As you can see, the outline adapts to the viewing angle. And if you don't like counting or you have a lot of materials, you can set this material offset to a high value and make sure the outline material is the lowest material slot. Now your outline might be slightly broken, like this one. So let's bring it to a pretty low value and see what its limits are. I really can't just give you a perfect thickness value, which removes all of these issues. You'll need to set up the thickness slider on your own, since all geometry is different, and some will have less intersecting geometry. The reason the inverse Hull method works is because of backface culling. This hides the flip normals, which we have in front of our duck, and shows the normals that face towards the camera, which are behind the duck geometry. In case you didn't know, backfaces are just flipped surface normals, because it's the back of a face. This lets you do some cool shader effects like this one. Transparent at the bottom, visible at the top. Thank you for watching this short video on 3D outlines. Like, subscribe, or share to support.